This meeting is being recorded.
All right. Well, welcome everybody to, it's our March Open Edge call. I'm John Cazalla, the team lead. Got Craig White here, who's my major helper and handy sidekick. I was hoping we would get Jean-Paul Smets today. He's been looking at, or he proposed to the group back, what was it, maybe November-ish, I think, kind of a portable form factor that I think looked really interesting for us to kind of take in and kind of evolve the requirements. So I was kind of hoping we could kind of drive some of the requirements, but we'll see. And then it doesn't look like we have anybody from the foundation yet. We'll give them maybe another minute or two. But there is the regional summit coming up. So if anybody's interested in going to that, is anybody on here planning on going to the regional summit?
Yeah, is it Lauren? I'm planning on going.
Oh, great. Okay.
I'll be there as well.
Who is that?
This is Alan.
Alan. Okay, great. Yeah, unfortunately, I can't make it, but maybe you guys, when you guys get back, you can kind of give us an update on how things went. So we've been working on kind of putting together the agenda and the track for, I guess it was this sustainable compute. I kind of drove that. There wasn't necessarily a specific edge track per se, but tried to get some presentations and materials around that in there. The other thing I wanted to talk about too is we've been kind of talking about our charter. And originally when this started, it was kind of being driven by contributions from Nokia around their Open Edge server. But we've been getting a lot of interest from other people, and the goal of this group is not to be specifically tied to just Open Edge, but other form factors and things like that. So that's kind of where the Jean-Paul Smets Rapid Space interest came in, was that he was looking at a form factor. What they do is they go into different locations that may not have persistent connectivity. They have a very ruggedized environment, and they're kind of global, so it's not specifically tied to even any one processor, because some of the regions they go into may have embargoes in terms of the technology. So they were kind of looking at 3 different CPU architectures, basically an Intel architecture, an ARM architecture, and then, correct me if I'm wrong, Craig, was it a Chinese specific architecture, or was it Russian? I can't exactly remember.
Yeah, I believe it was Chinese. It was because it was I forget the Hisense, or I forget the name of the processor that it used, but it was a Chinese specific processor.
Right. So they were looking at kind of, and what was interesting for them was their whole goal was to have something that you could throw into a carry-on suitcase. Rather than having to ship it, but basically kind of take it with you, bring it through TSA security, and put it in your carry-on. and be able to kind of deploy this in these kind of very ruggedized environments that um, the environments they were doing this with. I guess they're using kind of an off the shelf kind of solution today, but it doesn't exactly fit their needs. So that was kind of the goal of what Jean-Paul Smets was looking at, in terms of driving this kind of form factor. Hey, Delco. So, that was, kind of what I was kind of hoping to be able to talk a little bit more about with him if he joined us. Then the other topic was, again, our charter. So, if anybody, I want to kind of put that to bed if we think we need to expand the charter anymore, if we think we're happy with it. I'm thinking maybe give everybody maybe one more month to send, and send it to the mail list, and we can kind of compile it. If there's any revisions or anything that we want to change in terms of the charter and scope of our project. As Craig and I were talking about, there's some work going on in the modular hardware team in the larger OCP community that may be good to have them, Craig, I'm thinking maybe we have them come and do a guest presentation to this group. I don't know. What are your thoughts there?
Yeah, I think that would be appropriate.
Because what they're looking at is, a modular kind of, and that would fit really good with this Jean-Paul Smets kind of requirements, is that it gives, the ability to kind of swap out modules. So, there could be a compute module where you have the different CPUs that he requires on. It's kind of a daughter card kind of solution with kind of these standardized connectors through OCP to kind of drive those different plugins. And Craig, you were talking before we started recording about different form factors, I believe. Is that correct? That there's kind of two form factors for this
The
MH.
DCMHS. Yeah, there's several different form factors for the DCMHS cards. You can go to their wiki page and look at it if there are people are interested. It's under the server group, server project.
Okay.
I can probably post a link to their wiki page in the chat.
And like, is there a specific one that would be interesting for us, or should we have them present everything they're doing? Is there something that we would ask for specifically?
Well, in the past, they had one form that would fit in the OpenEdge sled. So that still may be of interest, but I think all of the form factors are probably at play. And the interesting thing is that, each of the CPU manufacturers have ODMs that make those modules with their CPU on it. So basically, you have a CPU and memory with standardized connectors that then connect into, either the Run BMC module for the management piece, and then obviously PCIe adapters and those kinds of things, and power connectors. So you can kind of assemble your own system, and then once you have the system, you can then swap out the module. So if you wanted to have an AMD or an Intel or an ARM based processor, you would be able to get just that compute module and replace it and leave all the rest of the mechanicals the same. It's kind of in a nutshell, the idea behind the modular modular server.
Right. Yeah, that would be interesting to be able to, have one common motherboard, and then, if you wanted to offer an ARM or a Intel or AMD solution, you could just swap out those from the DCMHS perspective, right? And then be able to have sort of hardware that's more or less generic and independent of any specific CPU. What would be the thoughts in terms of, say, like,
I just posted that link into the chat.
Oh, you did?
Folks
Okay.
would like to look at their wiki, so there's a link there. And, it would really, I think it'd be probably best for, folks to have to talk with them or to look at their material and the specifications they have. To be honest, I'm not totally an expert on it.
Yeah, no, I don't think any of us are, right? So that would be the idea, is to have them present to us.
But see that the second one there, I don't know if you're looking at it, but there's the MDino. It's a density optimized HPM. And so that's the one that was slotted for be made into a sled. So it would fit the open edge sled form factor. But like I said, that's not to say that, other folks may be more interested in like the full width or, some of the others. And obviously, it talks about the common redundant power supplies and the modular plug and plays, et cetera.
And like, would the idea be is that would we still keep the
Well, so I think that, the thing would be for, like for our group, for instance, if we were interested in this and we wanted to say, if you want to keep, say, the ruggedized form factors, right? So those chassis elements that would make it be ruggedized would probably be what the use case that we would have to put forward. We may want, and if you want it for telco use, they typically want, the neg 48 DC. You've got the NEBS requirements, those kind of things, which are around more of the housing. Obviously, some of what's on the inside, they do have to run during like a shake test for earthquake and that kind of thing, right? But still, those use cases would need to be defined, and then we could work with the group to then understand, is there anything that they needed to do from the DCMHS, side of things. I really wouldn't. I don't know. Perhaps you may not want a socketed CPU. You may want a board attached CPU. I'm not sure what the use cases may be that folks would have, but I think that's the role that I would see us playing in that area. And I don't know, it might be something that Joshua and Anton might have an opinion on as well. I think that might be the kind of thing that they are working on.
Yeah, Craig, I'm honestly catching up on. I had to open the open edge standard to try to relate what's kind of differing from what we have in that documentation and what you guys are speaking on right now.
Yeah. Well, what we're talking about now is if you look at the open edge chassis, it's a sheet metal enclosure. It fits in a 19-inch rack. And it's about 420 millimeters in depth.
Mm-hmm.
In the lower portion, it has redundant power supplies and a what we call a rack management controller that then has a BMC that's responsible for controlling the power. In addition to that BMC, it also has a built-in an Ethernet chip on it that then distributes the BMC connectors through the backplane to the back of the sled. Each sled then has its own BMC and uses that Ethernet connection for its IPMI. So that each server doesn't necessarily have to have its own management port. There's one management port for the entire chassis. The chassis then has, 5 slots. They're half U. the first of the half U in, say, the lower left corner is where the power supply and the rack management controller are. Above it, there's 2 slots, and then on beside it, there would be 3 slots. And that's in the, I guess I'm going to say, the classic Open Edge, because we now also have a 2U system that would have ability to have 3 sleds rather than 5 total sleds. But then the sleds can either be 2U or 1U, in which case you could either get 5 or you could get 3. You had 2 2Us and 1 1U. And then there's the in the 5G use case, we also have what we call a front hall gateway, which is an Ethernet sled that goes into one of those ports. And then additionally, they're on the back plane in that slot next to the power supply and the rack management controller. There's an additional power pin that's designed for a battery backup unit to be plugged into that slot. And that would backfeed power to the power bus rather than drawing from the power bus, right? And so that's kind of the Open Edge chassis in a nutshell. And there's a standardized interface on the rear of the chassis. It has a guide pin, a power connector, and then the high density connector for the network. Now, what we're talking about here now would be if you took the metal, and this is all basically, bare metal, if you will, just a sheet metal housing. And then in the sled, is another sheet metal that has those interfaces in the rear. But inside of that, instead of putting a monolithic motherboard, you could put this the DC MHS MDino form factor CPU and memory, along with then that, like I said, the Run BMC, which is the another OCP standard that has the a BMC chip on it and the CLPD and those things that you need to run the system. And then you could also have different kinds of PCIe slots and flyover connectors or cables to connect into the PCIe interfaces that's available on the MDino card. And so we're kind of switching gears and mixing metaphors somewhat and talking about like this modular server system in relation to our group, which typically talks about open edge sleds. But now we're saying, we've had some folks like John was talking about, John Paul Smets at Rapid Space. They have a 1U server. And so, it's a different form factor, but it's still an edge application. And so that's something that we would be interested in working on for him to produce those specifications so that, this is another way for us to express our use cases, which would be, do we want something that's rugged or do you want it to fit, a certain depth format or that? And then we could then work with, and not us as in the leadership of the project, but the community would work with the community of the servers that are working on this DCMHS project to then make sure that their form factors fit, that it has appropriate interfaces, those kinds of things. I think that's what John was referring to there in that. And I'm sorry if it was somewhat confusing. And I'm sorry if my explanation was confusing as well. We kind of covered a lot of ground there real quick.
Yeah. So for my past, I was familiar with the Open Edge, at least somewhat, because at some point the company I was working for was looking at making a rugged version, more rugged than the NEBS version of the Open Edge. But this DCM MHS, personally, I'm just not as familiar with yet.
Yeah.
So,
but see, it's just a board, right? It's kind of like the motherboard, and so then if you had, say, a military or some other kind of more, mining or other kinds of more rugged than you would need in say the 5G use case. So you just want to define, all you'd have to do really is define that sheet metal And then as long as there was a DCMHS card, that CPU card, right, along with, the Run BMC module that was rugged enough, right, because it does have connectors. So depending on, if those connectors meet your requirements, then you would be able to do that. And then, like I was telling earlier, because there are multiple identical form factor CPU cards that would come, and I said, Intel, AMD, and ARM, and by that really, I guess I would mean Ampere, right? So those are the kind of standard, ARM and then x86 of two varieties. And so you could then get that card, and then based on your customer's wants or needs, you wouldn't have to redesign your entire system as long as it was compatible with that modular approach, right? And so if you had then requirements on that modular unit, say if the connectors weren't, sufficiently rugged enough, right? Then you could probably work with them to define a more ruggedized connector for those pieces, because the intention is to have something that's modular, obviously, so you can swap those things out. And that's the kind of thing where we wanted to interface with that group to make sure that our requirements were there. So, and the telco group and then the Open Edge group in particular, the reason that we came into being was because in the beginning we were using the standard OpenRack version 2 systems that Facebook was installing in their data centers. And one of the things that we found is it had no EMI protection and it had no earthquake protection. And so we then came up with some retrofits for Zone 4 seismic, and then did the testing on that to ensure that it was compliant, and then added some new SLED components to make the EMI be accepted and to do that testing. And so that's kind of the way, those groups weren't interested, the rack and power group, the server group for the server sleds, they weren't interested in our use case. They were selling plenty to Facebook in the data center and to the, web scaling crowd. And so we kind of had to do that on our own for the telco. And so that's the reason that we're thinking the same approach would happen in the edge, because, someone has to put forth that use case and drive the specification for that, what's different, I guess you could say, right?
Yeah. So we're looking at, kind of these ruggedized and, constrained environments where, sort of the rest of OCP is just looking at a very, normal data center type environment. We're looking at like, hey, this is going to be out, in some rural environment, and, you don't really have that much control from an environmental perspective as to, dust and seismic activity and these kinds of things that you would have in kind of a more traditional data center. So one thing we would need to look at is these connectors that they have for this DCMHS. Are they would they be seismically okay? Like they may be great in a data center, and I think there's a smaller they're small enough that they could fit our use case, but are they secure enough that they're not going to shake loose, right? Because if you've got your CPU sitting on a daughter card and you put it under a shake test, is it going to come loose, right? So these are the kinds of things that we would need to probably specify in addition to what they've done. But like as we were all saying, this is kind of new areas for all of us. So what my thought was is maybe have them come and present to our team what they're doing. And as Craig was saying, as Craig shared here, there's a couple different things they're doing. Maybe we look at those, figure out which ones would be applicable to us, and then maybe evaluate that further. and see, will this, is this going to work? Do we need to augment this? Do we need to change it? And create additional specifications and maybe something different. Who knows? But we need to kind of look at it.
Got it. Just wondering about the specification on the ruggedness. So I have open the OpenEdge chassis Rev 1.4. Is that where I could find that part of the design aspect, or do we specify it somewhere else? Some sort of standards that we need to meet in terms of shake testing and connectorization, or at least the OpenEdge side. Can you guys hear me?
Yeah, I'm not quite. What was your question?
So I was looking at the OpenEdge chassis Rev 1.4. I was wondering, is that where I can find some of the specifications on the ruggedized standards that we need to meet for these telco side, or is that somewhere other document?
I don't know if it's Craig. Is it in that
Well,
one?
hey, Lucas, are you on? Or did you hear that question?
I think I found it
Yes,
actually, section 8, environmental and regulatory specs. I'm
Yeah.
assuming that 1.4 is the
Yeah.
latest rev from 2020.
yes, Anton. Actually, these we will find maybe the way these were published before was in this kind of monolithic contributions, and these are not all concentrated in a single. I understand that they're not concentrated in a single specification file there. You have to look through what was done before. We are actually contributing now to this kind of base specification now for the sleds. And through this kind of base specification, we aim to maybe enable the access to these and to enable actually other people to contribute better, and make it more usable, I guess, also. So yeah, they are there, but they are not in a single, as far as I know, not in a single contribution
So,
done there.
so Anton, I think what you may find is that in the, I think what Lucas is saying is in the sled specification, because when you do the seismic test, right? What you have to have is a complete system. You can't just seismically test a chassis, right? You've got to have chassis, the power supply, the rack manager, and then the servers in the sleds, and then they actually have to be powered up and typically mounted in a rack with power supply for the rack power, right? And so in the sled document, it goes into more detail about the ETSI and the NEBS GR core requirements that are met by those. If that makes any sense.
Yeah, I mean, I was just thinking if I use this from the top level, the OpenEdge chassis together with Sledge table of specs, I can check on our end for the communications telco side, whether these are any feedback in general, but also if we have this call with the other OCP counterparts presenting, I guess we should run some sort of comparison of, okay, this is what we need versus this is what they're introducing as potentially not compatible yet.
Yeah, I think the challenge for us, right, is that this group came together because there was this OpenEdge server. The original spec was kind of like the whole thing. They've just done a revision to it where they kind of made this a base spec. So the idea with the base spec is to say, okay, here's like this baseline, but then you would write like a more detailed specification for a specific implementation. And I think what we're kind of seeing is this group is kind of evolving where, okay, now people are looking at maybe beyond just the open edge server. Jean-Paul Smets was coming with his specific requirements, and maybe what I'm hearing you propose is that maybe we should even consider pulling out these specific requirements on what are those hardened requirements independent of any of this. Perhaps, I don't know. Go ahead.
Yeah. So I think one of the things too, so in a historical sense, John, so Lauren is on the call today, who's project lead for the Telco Project, which is the group that sponsors the Open Edge. And so in Telco group, we had a lot of detail on NEBS requirements, what was required by telcos for NEBS. And then in Open Edge, that was a very specific use case for 5G wireless. And so in the difference between NEBS and the things for the wireless is that the wireless has some different both temperature ranges and also size requirements that aren't necessarily in NEBS. And so it could be, I don't know how, if the telco group is still dealing with NEBS, but then in the telco group, there was, and there still is, like some documents from, say, AT&T and some of the other vendors on considerations for data center equipment installed in central offices, for instance. And so in those documents, there are some of the higher level specifications that a company such as AT&T was expecting for servers that would be installed to be used for telco applications versus the Open Edge, which is a subset of those even that's required for the wireless environment. I mean, I know I'm really not answering your question directly, and I'm sorry, but this is potentially a place where, we would be more than happy to work on, say, a contribution that would define these in a way that would make it easier for those people who come, after to not have these kinds of issues. Right? It would be a great way for you to get involved. I think in my email to you, I said, you're going to get out of this as much as you're willing to put into it. And so, this may potentially be one of those things that if you could help, clarify it in your mind, it may help the wider group. And then obviously it may even have applicability, like I said, even to the telco group, not necessarily just the edge part. As we move farther kind of away from wireless and telco.
Yeah, because I guess Craig, what my thoughts kind of been is, okay, telco kind of had these hardened environment, or hardened requirements, but perhaps when we start looking at some of these other use cases, specifically this rapid space solution with Jean-Paul Smets, that's even maybe beyond NEBS in terms of like, hey, I want to toss this in a suitcase and throw it in carry on, right? That may have additional requirements that are even beyond telco, NEBS compliance. That starts to even get, because telco, I don't think they expect to toss stuff in a suitcase and throw it in carry on and take it to so maybe it's telco, but then even more more rigid, more rugged. I don't know. Just kind of my thought process here in terms of where this could go.
Yeah, I'm not sure. Hey, Lauren, do you have any thoughts on this?
Yeah, the telco group in particular over the years basically either took requirement documents from the potential customers like AT&T or Deutsche Telekom, and created products that we contributed back to OCP as hardware requirements. So I don't think there was ever any really overarching strategy related to environmentals, except for the fact that they were different than data center. quite frankly. Does that make any sense?
But yeah, basically, Lauren. So what you're saying is you guys really just kind of relied on like the Telcordia GR requirements for devs, and
especially the AT&T documents, since they were slightly different than the Telcordia stuff, but
right.
followed in that path and were acceptable to both AT&T and most telcos.
So I guess
the most irritating one was whether or not I needed air filters on the front of products and stuff, right? So
yeah. So Anton and Joshua, what maybe you guys could educate us a little bit too on what you guys are doing and what you're looking at.
Yeah, that's a good starting point. I don't know, Josh, did you want to chime in first, or?
Yeah, I mean, I can say something. So, if you guys are, I'm maybe starting with an assumption that you know a little bit about Vertiv, but maybe you don't. What's our current knowledge here?
Maybe assume nothing.
Nothing. Perfect. That's easier. Okay, so so Vertiv overall, the company itself does data center infrastructure, starting from hyperscale all the way down to telco, and including enterprise data centers into data closets. But we do the infrastructure side, so mostly racks, cooling, power distribution, UPSs, so on and so forth. So everything that supports the compute without the compute itself. Historically, we have not done a great job supporting OCP because it's a highly, as you guys know, highly commoditized market, hard to squeeze any margin out of it. There's been an effort to refocus and just get more involved to see if there's something that we can do to contribute, steer the technology, and find a niche in here somewhere. So Anton's taking a lead at the company level to kind of set up individuals to be deployed into the various projects within OCP. Some of them we have a direct, we have more of an involvement. We think there's an application for us. There's other ones that we just wanted to be aware of and kind of get some more information. The open edge kind of falls into the, hey, we're trying to figure out what this is because we're not really familiar with it that much. Anton had some experience with this from his previous role, so we were able to kind of gain some knowledge from him there. But we're really in an exploratory phase. See what this project's about. See how we contribute, or if we should contribute, that sort of thing. So that's really what I think we're all about. Anton, I don't know if you want to add anything to that.
Yeah, I mean, I just wanted to add also, John and Craig and team. So we have this specific group within the Vertiv team, which is solutions side, and that involves somewhat of a edge side, maybe not telco edge, but maybe retail and such systems like that. And that comprises of perhaps a row of cabinets with in-row cooling, in-row power, and perhaps some management appliance as well that centralizes all the information from the power cooling and also potentially the servers. And so it's not necessarily ruggedizing that, besides just making it simpler to deploy, perhaps. So Josh mentioned I had some experience, and that experience did include some, like a defense side where we have servers going into the planes or submarines. So
yep.
I have some familiarity and have contributed to develop a type of a ruggedization level spec that I could potentially share with you guys for review, but it was predominantly, I would say, the mill standard 810H that is commonly referred to from the defense side again. I do think there's a equivalent type of not defense, but just airborne specifications that folks typically use. I just can't remember the name of that right now.
Yeah, I mean, it sounds like what you're describing. So that if you remember back when I kind of opened this, we're kind of looking at our chart, because I think when we started this, it was very, as Craig was saying, it was kind of very specific to this open edge server. What we're seeing is that there's a lot of interest for these other use cases like you're describing, perhaps even outside of telco. But like right now we're hung under the telco group, so like we're kind of a daughter project there. So that's kind of where Lauren fits in, because he's the telco project. We were kind of forked off very specifically to be this open ed server. But a lot of the interest we're seeing, I think, from the community is people, I guess, are finding us because we're called Edge, and like you're saying, like past history for me, I worked on positive train control where you had a computer on a train. So like it's not telco, but that needs to be in kind of a hardened environment, right? And like you're talking about, like if it's on a submarine or a fighter or whatever, there's this kind of niche that is kind of this more ruggedized environment. But like so that's why it's interesting to kind of, I think, have this discussion and kind of understand what you guys are looking at, and kind of like we came out of this telco branch and have a very specific thing that we were doing. But that's why we're kind of saying like, hey, let's maybe relook at the charter, let's maybe rethink what we're doing, maybe this goes beyond that. And there are these use cases. That's kind of also where Adiko fits in, because she's bringing in another avenue that was kind of outside of the original scope we had, which was this open edge server. Because everybody's kind of looking at this edge as just there's a telco aspect to it, but it's much more than just telco edge. It could be retail edge, could be mobile, transportation edge, all this kind of things. And is there stuff that isn't being addressed anywhere else in OCP, and is this something that the people in this group want to take that? That's kind of the question.
Yeah, no, I understand that. Yeah, I mean, I'm interested in if kind of figuring out what makes sense, but also hearing what the server side is going to look like, and whether there needs to be some sort of new rack design specific for that, or a new way to distribute the power. Do we go to DC power shelves like the OCP or V3 spec or not? Yeah, kind of expanding beyond just the server bricks or modules themselves. I don't know what the charter is right now, actually. Maybe I should get that in my brain as well.
Yeah, take a look at the charter, because that's what we're interested in, kind of reevaluating. And if people, this is everyone's community, right? So if there's things people want to drive, and it seems like we're the only place in OCP that this is falling into, because everything else has kind of been a very more traditional data center environment. Maybe we start to evolve this. That's kind of where we are. So,
John, I'm thinking I will also suggest a counterpart of mine that is involved on this kind of rugged server side. I think it'll be even beneficial for, kind of mutually beneficial to get that interchange. Now that I'm aware, like it's under telco, but not necessarily we have to constrict ourselves that way, right? So,
right.
Actually, it looks like he'll dial in right now, maybe even. So we'll see.
Yeah, so that's why this John Paul Smith, John Paul brought us this back in. It was actually probably mid last year, actually, but we really started kind of talking about it in probably the October, November timeframe, where all of a sudden he's talking about this, like, hey, I got this thing, I want to toss it in a carry-on, and I'm going out to these remote regions in Africa and setting this thing up, and it's to the point where like they have to disconnect from the internet because the internet needs to be used for the schools during a certain period of time, and there's only so much bandwidth. And so, his constraints are like, this thing isn't even connected 24/7. It has, it's cut off so that the bandwidth can be used for educational purposes during a period of the day. You know, so it started to put some interesting spin on, you know, everything that we were looking at, and you know, that's why it's interesting to kind of understand his requirements a little bit better, and you know, help him drive his requirements, because I think it would help. You know, where you guys are even talking about is, you know, stuff beyond just NEBs, right? Because that's just very telco specific, but doesn't maybe even cover everything you want from a ruggedized environment.
So this is Alan. Just sort of jumping in here, if I'm here. So are you saying the charter you're opening up to looking things from a fresh, clean sheet of paper? Or obviously OpenEdge has been around for a while with the various implementations. Are you taking a grounds up view of this as well now? Is that what you're saying?
Yeah, I mean, I think the idea is, you know, us as a community, do we feel that it's the way that it's there, is it serving our needs? Do we feel that this community needs to expand, go maybe to a different direction, you know, not maybe a different direction, but become, you know, larger?
Hang on a second. So Alan, have you read our charter by any chance?
I have not yet, no.
Okay,
well,
so
I got the introductory emails, but yeah. So
yeah. Okay, so basically our charter is very broad, right? Because you don't want to be having to recharter groups all the time. And so the question is, read the charter and understand if there's something that's not, you know, you want to be much more open and permissive than restrictive. And we've tried to do that. What we've tried to do now is before there was a lot of prescription around OpenEdge. All of that stuff has gone away when we talk about servers, you know, and the question is, are you able to do the work that you would like to do in this group, or do we need to make modifications to the charter?
Okay. Right. I got it.
It's not that we're throwing away the old charter. The charter is still valid, and we believe we have great latitude in what we can work on. We just want to make sure that the rest of the community is in that same situation with us.
Okay. Yeah. I just want to give a bit of context, right? So I'm a hardware engineer. I'm a system architect. I come from the high performance compute side of the world, specifically accelerated computing and FPGAs. That's what I'm really known for. But I've been the technical lead of the OCP high performance compute subproject. And we're a bunch of crazy dudes that are actually really looking at the data center from the ground up. So much so that we're getting rid of 19-inch racks and replacing them with walls, and we're plugging modules into these walls. And the modules are of the order of, you know, the modules you see, the OAM module, the SXM module with the H100s, etc. That's the sort of thing that is our building block, okay? And the argument we're putting forward is computing today, including the edge stuff, is all based on the 1981 IBM PC. A regular server today is still pretty much an IBM PC from 1981. And clearly our industry needs have gone off on a tangent by looking at NVIDIA's DGX box, Tesla Dojo, Google TPU, just look at them all. And everyone's gone in their own direction, yet it's completely closed. So if I'm a system architect and I love NVIDIA's GPU, but I want Intel's CPU and I want AMD's FPGA, and I can't do that. And if I'm a silicon startup like GraphCore or Samba Nova, I can't just build a module and deliver it. I've got to build a chassis. I've got to build a rack. I've got to build a data center. I've got to build a software stack. So I've got to spend $1 billion of venture capital money before I can even begin to try and compete with NVIDIA. And then NVIDIA's moved on 5 more years by the time I've got there. So we need an IBM PC for today's computing demands. And that's what we're trying to do. And look, we have got zero backing from any of the big buys. We're just so revolutionary in our thinking that nobody's really, they just think we're crazy dudes, right? And for good reason. But I'm saying either I need to be an Elon Musk with $1 billion in my ass pocket, and I'll do it myself, or we can do it as a community in OCP, and we're trying to do it as a community in OCP. Now, the thing is, when you think about this from a modular level, the way we're doing this, it's easy to say this could map into the edge. It could be a telecom box on the side of the street. It could even replace the PCs in our houses, where our kids are gaming now with kilowatt PCs, with gaming PCs, and they're boiling their rooms. And if we actually change the design of a house to put the thermal management of the computing hardware into the design of the house, you could just buy the modules and plug the modules into the wall and not heat the building. It would be part of your HVAC system. So it's all of that sort. So it's really grand, big vision thinking. But I think the edge is a big win for us. Now, then you throw in NEBS compliance and you throw in ruggedization. You're going to look at what we're doing. You're going to say, you're crazy. How are you going to make that rugged, right? But that's the problem, right? It's easy to say why you can't do something, but we're trying to start from a clean sheet, and we're still in concept stage. So what can we do something? So I guess my interest is, I think there's actually probably, my thought process is, we have a couple of building blocks that we could build a supercomputer for the government, or we could put a telecom box on the side of the road, or we could put a gaming machine in somebody's house, and a local, a private cloud in somebody's office, or whatever. So I'm trying to, instead of, somebody did say, oh, it's all commoditized in OCP, therefore we can't make any money. Well, the people with the pieces, the widgets, can make money. I think the challenge is possibly the Dells and the HPs of this world won't be able to make so much money these days, because it'll be in the infrastructure design. So if you're putting the infrastructure pieces together, you can make money. If you're making these silicon or media modules, you can make money, but probably there's no chassis money going on there in the way we're thinking about it anyway. So I guess my question is, and I'll shut up, does your charter cover looking into all the crazy stuff we're doing, or would you be interested in that, or is that off tangent for you?
My view is it's interesting, and yes, kind of what Craig's talking about is, it's very general, but it's also very general, and it doesn't give you kind of these guide rails of like what we do want to look at, perhaps. So maybe there's a general part, but then there's like some things that specifically we want to talk about. Maybe it could be we want to talk about this organization, and could be tying in with what you guys are looking at, and bringing that ruggedization, right? Because if I'm understanding you correctly, it's we could kind of be this distributed part of kind of the high performance computing, moving things to the edge because you need low latency or whatnot, right? So
right.
Well,
I see the computer is one big machine: the cloud, the edge, and the intelligent IoT. So it's one piece of software across the whole lot, is it? And you put it to minimize the energy and to increase sustainability. So
like I would say yes, our charter today is probably broad enough to cover that, but it doesn't specifically talk about that. So like you wouldn't know that like that's what we're looking at doing, right? So maybe yes, it's very broad, but perhaps maybe it needs to be a little bit specific in some section as to like these specific things we want to look at or cover.
I mean, we're very specific in what we're trying to do. We've got to that point in concept.
Okay.
There's a ton of holes in it, for sure. I mean, there's a long way to go. And anyway, I guess what I could do is I could maybe just give you a quick, on one of the meetings, I could just give you a quick overview of what we're up to.
Oh, that'd be great.
Yeah, I'd be interested in that as well.
I mean, it is, like I say, you'll be shocked, and I'm sure you'll be. I mean, it's a case of if there was interest, then then we dive into the details. But
can I pencil you in for next month?
Sure. I am going to be at the regional summit, so as long as it's around that. But yeah. All
right.
Hey, I just wanted to introduce, I mentioned someone was going to hop on, Vincent Chung from Mercury Systems, and he has quite a bit of experience with some of this ruggedization. I don't know, Vincent, if you want to introduce yourself real quick.
Yeah, I see some familiar faces here. Craig, I recognize your name. I'm the product manager for the blade systems, the rugged blade systems at Mercury, and this is kind of a timely meeting because what we've in fact done is we looked at the Open Edge Charter and we kind of realized that, hey, you know, this thing is open to interpretation, and at least for the entire rugged x86 blade portfolio at Mercury, we've kind of tied our horses to Open Edge. And we've done a product launch and we've released a, excuse me, a ruggedized version of, I mean, we've essentially created a compatible ecosystem of rugged x86 modules that can, I mean, that essentially what we've done is we created a system that ruggedizes the Open Edge architecture. We used an ODM to create an entire portfolio of blades, and we took the Open Edge spec and we kind of we created this architecture where we can essentially insert any standard ATX motherboard, you know, 20 to 24 pin ATX motherboard, and interface it with the Open Edge chassis backplane and turn it into a rugged blade, right? And our entire pitch to our customers, which are mostly military, is, you know, right now you guys are using a slew of blade systems from various vendors, and it's painful because our customers at the edge are trying to sustain these things for 3, 5, sometimes 10 years. And when they go buy spares, they have to buy a set of spares for every vendor. Quite literally, we've got some Navy systems where, you know, you've got a Mellanox switch, you've got, you know, a storage box from someone else, say Isilon, you've got some Mercury gear, and you've got some IO boxes, and they have to buy like 5 to 6 power supplies just to keep a tally of them, right? Because they want to maintain 10% spares. We'll multiply that by 6. And our entire pitch has been, well, look, you know, we can lean on the Open Edge ecosystem, and you can reduce all that to one set. And hey, look, you've got alternatives as well. It's not just Mercury stuff. It's not just Nokia stuff. It's anything in the Open Edge ecosystem. And the barriers to entry are relatively low. Say one of us croaks, well, you go get an ODM to do it to that standard, and it'll plug in and it'll work. And we're still pushing it into our market here, but it's kind of the way we see things going.
Interesting. So yeah, I totally see what you're saying about, you know, especially with like x86 hardware, it changes so rapidly that, you know, yeah, you can't get the replacement because now it's some other version of the processor and all this other things because it revs every, you know, year, right? And so interesting.
Right. And you know, if I could just condense it into a really short elevator pitch, and forgive me, I kind of hopped onto this meeting a little late and I haven't really prepped any talking points, but the entire vision around the Mercury product is, hey, you know, you're the government, you're trying to insert a bunch of infrastructure, right? And traditionally, what the government has done was they put out an RFQ and they tried to get vendors to build this big monolithic system. And I like to equate that to a race car, right? They get people to build a, I don't know, let's just say a 10U computer that's designed for some environmental specification, and it's going to fulfill a certain number of performance specifications. And it's great. It's going to go, it's going to do the thing. It's like a race car, right? You pay for it, it does what it says, it speeds along. But my pitch has been, well, it's only going to work so long as that road is straight. The road isn't going to be straight, it's curvy, right? And so I kind of equate an architecture tied to a spec like Open Edge as not like an F1 race car, but I don't know, call it a Camry Sport, right? You're gonna be able to pump the brakes, you're gonna be able to take those turns, and you're going to be able to, because there's a platform and there's an ecosystem of a product that lets you take what's already out there, and maybe it's not a drop-in replacement, but you can take it, and a lot of the engineering's already been done, and ruggedizing it is really just an increment. And so our pitch is, look, you get into this ecosystem and you can react a lot faster to your own requirements, to what's coming out in the data center world, right? But you've got to be on a platform that's a little more flexible than your kind of traditional approach. But that's the analogy.
Interesting. Hey guys, I see we're losing folks. Maybe we can we continue this discussion on the email list? That would be great. And
yeah, hey John, I'm sorry, I had to step away for just a minute, but I just came back to the end. And I'll respond to Vincent for a minute. You know, that's actually the whole beauty of an OCP model. And you know, when we were talking about the base specification, I'm not sure if you were on then. I know Anton was, maybe can catch you up, but the way the OCP specs have been evolving is we've now come up with what's called a base specification, and then a design specification, and finally a product specification. So in a base specification, you would then not specify the CPU. You may say, I need a CPU, I need some memory, I need this and the other at a very high level. And then the design would then say, oh, I'm going to design this with a Intel CPU and DDR memory version 4, DDR5 or 6, whatever you happen to be. And then the product spec, you actually come up then with the BOM and everything necessary to produce that product. And so each one of those specifications is then designed to give you that platform for when you want to make a modification. You may take a design and you may modify that design ever so slightly to make a new product. But if you need a different design from the base spec, you can start with the base spec, make a new design and a product, so that everything is intended to be modular in that respect from the specification standpoint. So it does exactly what you're saying. It reduces your NRE cost on a new product and gives you, you know, more flexibility, quicker time to market, and it does incorporate all of those the additions that come from the rest of the community. So if you want to use something that's coming, say, from the storage group or one of those other groups, you're able to do that.
Yeah, I follow Craig, and of course we realize that part of the beauty as well as the drawback of you know open bus and board specifications is that vendors can interpret them, right? And there's always going to be that tension between, well, how close do you conform to the standard, and you know how far do your value adds pull you away from it? But I mean that's a whole nother can of worms, right?
Yep.
Yeah, that's no worries, and the you know we have that's really the goal of, like, say in this case the open edge chassis, the open edge so the open edge chassis has two different components as well, boards. Okay, it includes a power supply board, power insertion board, and then a riser. And the schematics for those are online, and the design files are online, so that you can actually take those and make an identical copy. And you expect people to do that because at the end of the day, the sled that plugs into that needs to have that level of specification to ensure that it's interoperable. And so there's two different types of specifications, the OCP. There's the inspired, which means that it doesn't meet all the specs and the schematics aren't out and the BOM and the step files, those kinds of things aren't available. But then there's the OCP accepted, and it includes a complete design package so that you can make a duplicate of that part. Right. And so you, as a contributor, you're able to decide how much of that you'd like to contribute. So if you want to create an ecosystem, like in the open edge case, we put forth all of those specifications so that other people could make sleds that they maybe had IP in that they didn't want to give away the designs for their sled motherboard. However, you wanted to be sure that it would plug into and interoperate with all the other available sleds, right? So that structure is here for you in the OCP.
Yep. Yeah, I'm familiar with both the OpenEdge the chassis specification as well as the sled specification, and we followed those
Right.
closely when we were running our own design.
Sure, sure. But I'm just saying, it's not just like that for OpenEdge. It's the same way for OpenRack. It's the same way for the servers. That's when we were talking about the modular server and stuff.
Sure.
But yeah, I'm sorry. We are over, and I'm sorry. We probably should go on for next month and carry this on the mail list. It'd be great.
Yeah.
Yep.
Yeah, let's do that. I appreciate you jumping on, Vincent and Anton, and yeah, let's keep the discussion going on the mail list, and then we can pick up next month again.
All right, sounds good. Take care, guys.
Okay,
All right,
great.
thank
you.
Thank you. Bye-bye.
Bye bye.
Bye.
Bye-bye.